planet. Four and a half billion years ago, the Earth was a very different world. Under layers of thick gaseous clouds was a planet still hot from its birth, with an atmosphere both dense and crushing. Bathed in filtered red light were oceans far deeper than those of today. And there was one other great difference. The early planet was probably only a tenth of the size that it is today. But it was to grow, and that chance and violent growth would prove crucial to life's history and to what we are today. The early solar system was far more crowded than now. Where today the four inner planets orbit, 4.5 billion years ago were scores of smaller planets orbiting the sun. Orbits of some were drawn by gravitational force towards each other. Encounters of awesome magnitude were unavoidable. The force and heat of those collisions melted the rock, but gravity would hold the two together and then weld them into one. With each collision, the planet would grow larger. We believe that of the four innermost planets, Mercury was formed by only 1 or 2 such collisions, while Venus, almost the size of Earth, was formed by 8. Mars may have escaped any collisions. But Earth grew largest, perhaps from as many as 10 impacts. And the last impact, 4.5 billion years ago, would have a profound effect upon our world. The giant body crashed into the center of the planet and gave Earth its iron core. The lighter debris was cast off into space and then drawn into orbit around the enlarged planet. For some millions of years, the Earth had rings like the planet Saturn. Smaller collisions continued, and from that debris was born our moon. It was chance and chance alone which made our planet larger than any of the other planets close to the sun. And somehow, somewhere in this chaos, life began. But quite where is open to conjecture and debate. But the challenges to life were daunting. The early solar system was still a violent place. Asteroids come hurtling out of space, attracted by the greater size of the planet. And on the face of the Earth today, we can see the scars of recent collisions. This crater in Arizona is well known. It's the Barringer meteorite crater and was gouged from the surface only 50,000 years ago. The impact crater is huge, 1.2 kilometers across, just under a mile, and it was thought that the size of the meteor must have been the same. So perhaps buried in the ground was a fortune in iron and nickel. In the early 1900s, the Standard Iron Company was formed by Daniel Barringer to dig out the perceived wealth.
When my grandfather came up this ridge and looked at it, he imagined that the object that made this hole was at least as big as the bottom diameter of the crater, which is, again, more than half a kilometer. He thought this would be millions and millions of tons of nickel iron, and it would be commercially immensely valuable, that he could make millions of dollars here.
The mining venture lasted 27 years, and in today's money cost around $10 million. But nothing of any value was found. But while the mining venture gained nothing except a useless shaft,
Ready? There it goes.
there was to be a winner after all. It was science. In 1928, a paper was published which concluded that the mass of the meteor was far smaller than the size of the crater. Further mining was called off, and shortly after, Daniel Barringer died of a heart attack.
I think I could have easily made the same mistake because it's such a large hole, and it's intuitively, it seems like it would have had to be a huge rock that would have made it.
In fact, the meteorite which caused this crater was no larger than the perimeter fence around the mine shaft. Science learned it was the force that was as critical as the size of the object. But about 4 billion years ago, the Earth was hit by a massive space intruder, 10,000 times larger and 1 trillion times heavier than the rock which grazed the Earth in Arizona. This is an impression of the relative sizes. The largest is 500 kilometers. That's over 300 miles across. Earth may have been hit as many as 6 times by an asteroid this size.
You have a 500-kilometer object moving at 20 kilometers a second, stopping in 20 seconds, delivering all of its energy in doing so, and you produce an enormous explosion. The amount of energy that is released in this event is more than enough to evaporate the world's oceans.
A massive asteroid from outer space heads straight for Earth. It's as large as the one that impacted over 4 billion years ago. This computer simulation has been made with the scientific advice of geophysical experts to show the effects if the impact were to happen today. The asteroid's diameter is larger than the main island of Japan. Even though it is moving at over 720,000 kilometers an hour, that's almost 450,000 miles an hour, the asteroid appears eerily slow because of its size. The actual impact happens in the Pacific Ocean, just under 1,000 miles south of Japan. The crust of the Earth is peeled away like an orange skin by what is called the crest tsunami. Even the deepest part of the Pacific Ocean looks like a thin film. Huge chunks of debris the size of city blocks are hurled into the air. The entire Japanese archipelago is disintegrated, as is some of the Asian continent. The shattered remains are hurled out into space way beyond the atmosphere to bombard the Earth with deadly intent when they re-enter. At 7,000 meters, 23,000 feet, the rim of the crater is higher than many mountains on Earth today. The size of the crater would be a distance of 2,500 miles or 4,000 kilometers. And this is just the start. An experiment was carried out at Hokkaido University in northern Japan to try and discover what could happen to the rock bed at the point of impact. A tiny rock was put into a special oven that could cook the sample to a temperature of over 2,000 Celsius, 3,600 Fahrenheit. As the temperature rose higher, the rock began to melt and boil like water. The gas produced is called rock vapor.
The rock vapor, when we generate this rock vapor, it will expand extremely fast. It expands so quickly that it can cover eventually the entire planet. When an impact hits, it's not just the crater that forms, it's not just the area where the impact occurred. It's all the heating that's created in the atmosphere and around it. So heat really is the killer.
Moments after the impact, rock vapor, the temperature of the sun, begins to engulf the world. Could any life at all survive this impact? Immediately after the impact, the rock vapor rises up from the crater in a dome, then spreads out in all directions across the globe. 3 hours after the impact south of Japan, the expanding wall of vaporized rock reaches the mountains of the Himalayas. The perpetual snows are instantly evaporated. Soon the wall of fire reaches the Amazon, the furthest distance from the point of impact. The forest spontaneously combusts even before the rock vapor arrives. Just 1 day after the impact, the entire planet is covered. Every living plant or creature is vaporized. It's been estimated that this vapor would cover the entire globe for almost a year. It would be as if the sun had come to Earth. The ocean would start to bubble and boil. And as the water evaporates, the oceans would drop at the rate of 5 centimeters or 2 inches every second. Even the salt deposited on the ocean floor vaporizes, and then the very bottom of the sea melts. Nothing is left untouched. One month after the impact, the surface of the world has been sterilized. The oceans have vanished. All that remains is the superheated bedrock. It is thought that an impact like this happened 6 times in the violent past of the Earth's history. If there was life, it was assumed that it too would have been wiped out, only to begin again.